Hey everyone! Welcome back to BugNoJutsu, the ultimate place where coding meets clarity. Today we're tackling a really interesting Leetcode easy problem. Valid word. Problem number 3136. It's a perfect mix of string handling, character classification, and logic that often shows up in interviews. We'll break it down line by line, example by example, and by the end you'll master it. Let's jump right in. So what's the problem asking us exactly? We are given a single word, and we need to determine whether this word is considered valid based on some specific conditions. To be valid, the word must satisfy all of the following rules. It must be at least 3 characters long. It must consist of only digits and English letters. No special symbols, no punctuation, nothing else. It must contain at least one vowel. That includes both lowercase and uppercase vowels. It must also contain at least one consonant. Again, either uppercase or lowercase. If all these rules are met, we return true. Otherwise, the word is invalid, and we return false. Let's walk through an example to really understand how this works. Take the input, 234 ADAS. First, check the length. It's 7 characters, good. Next, look at the characters. We've got digits like 2, 3 for allowed. Then letters like A, D, A, S, all valid alphabetic characters allowed. Do we have at least one vowel? Yeah. And our vowels check. Do we have at least one consonant? Yes, D and S are consonants, check. So this word passes all 4 rules and therefore the output is true. Now let's break down the logic behind the solution. Without diving into actual code, we start by checking the simplest condition first, the length. If the word has fewer than 3 characters, we immediately return false. Then we prepare a set containing all vowels, both lowercase and uppercase. Why? Because we need to detect vowels efficiently, and sets allow O1 lookup. Next, we loop through each character in the word. For each character, we do a classification. If it's a letter, we check whether it's a vowel or consonant. If it's a vowel, we increase our vowel count. Otherwise, we treat it as a consonant and increase the consonant count. If it's a digit, we ignore it, because digits are allowed but don't affect vowel/consonant counting. However, if we encounter any other character, like a punctuation mark, symbol, or whitespace, it's immediately invalid, and we return false. Finally, after scanning the entire word, we check if we've found at least one vowel and at least one consonant. If both are present, then and only then we return true. Otherwise, it's not a valid word. Let's analyze the performance. Time complexity, ON, where N is the length of the input word. Why? Because we iterate through each character exactly once. Space complexity, O1, we're only using a constant size set for vowels and a couple of integer counters. No extra memory based on input size. Here are some useful insights you can take from this problem. Always validate the simplest conditions first, like string length, to avoid unnecessary work. Using sets is super efficient for membership checking, faster than lists or strings. Understanding the difference between isalpha and isdigit is crucial. These are powerful built-in methods in Python for character classification. Also, be cautious with logic like if val.isalpha. You must call it like a function with parentheses, or you'll accidentally be checking if the method object exists, not whether the character is alphabetic. This type of string validation is commonly used in real-world applications like form validation, password policies, and input sanitization. And that wraps it up for today's problem. Leetcode 3136, valid word. We explored how to build a clean and efficient solution using simple Python logic and a bit of smart thinking. If this video helped you, be sure to like, comment, and subscribe to BugNoJutsu. And let me know in the comments, what's your favorite Python string method? Thanks for watching. Keep coding, keep crushing interviews, and I'll see you in the next one.